Hi, good evening, everyone. Welcome for today's session. So today, yes, we can. Today is the sixth day, right? So we'll be look at one use cases for tomorrow today. Right, we are going to work with that. Fine. So let me share the screen. So yeah. So just a minute. Let me share the screen now. Getting loaded. So yeah, I'm taking. So trade analytics, and we'll try to come. So just a minute, guys. Keep uploading. So yeah, just a minute. My bad. Just keep loading. Okay, wait. So yeah, let me share the screen now. Yeah, the issue has been fixed now. So there is an issue ultimately. Yes. Okay, guys. So I hope everyone is back. Okay, fine. So very first day we discussed about. So today, as all of us aware that in December we are going to look at trade analytics program. Trade analytics program. So what is trade? Right. So trade is the buying and selling of goods and money. Right. So in trade, we have buying or selling of goods. Some transaction happen by using trade. There is a stock, equity. So there are multiple things we are going to look into that. So in trade analytics program, it is 16 hours program. Okay, overall, it's going to be a 16 hours. Okay, it's going to be a 16 hours program. So every day we are used to go 1 hour. Okay, every day we are going to use 1 hour for this training. And very first day we discussed about day one, we discussed about machine learning application on trade domain. Second day we discussed about CRISP MLQ. Third day we discussed about data pre-processing. 4th day we discussed about data pre-processing. 5th day we discussed about data pre-processing. 6th day we discussed about data pre-processing. 7th day we discussed about data pre-processing. 8th day we discussed about data pre-processing. 9th day we discussed about data pre-processing. 10th day we discussed about data pre-processing. 11th day we discussed about data pre-processing. 12th day we discussed about data pre-processing. 13th day we discussed about data pre-processing. 14th day we discussed about data pre-processing. 15th day we discussed about data pre-processing. 16th day we discussed about data pre-processing. 17th day we discussed about data pre-processing. 18th day we discussed about data pre-processing. 19th day we discussed about data pre-processing. 20th day we discussed about data pre-processing. 21st day we discussed about data pre-processing. 22nd day we discussed about data pre-processing. 23rd day we discussed about data pre-process Fourth day, we discuss about EDA. Sorry, third day it's EDA and data processing. In this day, we covered only EDA. And fourth day, we discuss about data pre-processing. Yeah, we have started this Thursday, right? Yeah. So today is, I think, fifth day. Today is the fifth day of training. So today, fifth day, we are going to talk about some use cases of some algorithm. For example, we have a supervised algorithm, supervised machine learning, and we have an unsupervised machine learning technique. So quickly, we can look at the type of supervised learning. Then we can jump into the main topic of that. Okay, fine. Okay, so now, so all of us know trading analytics. So the trading strategies that identify the pairs based on the return time series. So we identify the pairs by incorporating firm characteristics. The machine learning has gained a momentum and been widely applied in various fields. All of us know, right? The machine learning algorithm widely used for various fields, but most commonly it used for finance also. In financial sector, the application of machine learning is huge. Okay. Yeah. So there are various techniques we come to know. First of all, let me talk about supervised machine learning. Now you look at that, we have a machine learning. So first, let us understand what is machine learning over here. Then we will understand supervised and unsupervised. Then we will talk about clustering. Then we will look at today's scenario is like that. So we are trying to what is machine learning. Then we will talk about what is supervised, what is unsupervised machine learning. Then we will talk about clustering. Then we are going to talk about k-means clustering and use cases. This is our today agenda. So let me talk about machine learning. What is machine learning will give? See, in machine learning, in the machine learning technique, we used algorithm, right? We build algorithm or we construct algorithm. We are constructing algorithm to learn the pattern in the historical data sets. Learn the pattern in historical data sets. So every company maintaining some data set, right? In server or cloud, in their server, database server, they have a database management and they're maintaining the data. So in the server, they are maintaining the data. Okay. So they maintain the data. So we need to access the data. So when you want to build any model in machine learning, the first primary step, what we understand, business and data understanding, right? So in business and data understanding, once you understand the business problem, objective and constraint, then you have to look into the data. You need to look the data, how to access the data, or how much data you're going to use. Right? So that comes to the picture. Yeah. Data understanding. So in data understanding, you'll come to know the data. What is data type? What are the data types? How do you collect the data types? So all things can be designed in data understanding. So what do you do now when after data understanding? You need to access the data, and we do data pre-processing. So before data pre-processing, we need to access the data. So that will be from database. In the database, you are access the data. Okay, fine. So then you will be working and further. Okay, so once you get access the data, this is historical of data. So you are build the model. You are building the model. Building the model is nothing but algorithm, creating algorithm AX1 plus BX2 plus CX3, right? We build the algorithm. The algorithm. So this algorithm we are using for our model to predict the data. So when you are machine learning algorithm, we have two type of machine learning algorithm. We have ML. Machine learning, we have two type. One is called supervised. Another is called unsupervised machine learning technique. Supervised machine learning and unsupervised machine learning. When come to supervised machine learning technique, we all know dataset. The dataset contain Y output. That means it's a labeled data. The Y is nothing but it's a labeled data. Correct? And another dataset which is contained unsupervised machine learning. That means all the input is considered as a x1, x2, x3. All the variables are considered as a input. X1, x2, x3, x4. These all are considered as a input as well as output. Combination of input and output. Combination of input and output. What is happening in the supervised machine learning? First of all, in supervised machine learning, first let us look at unsupervised, then we can come to our topic of unsupervised machine learning. So in supervised machine learning x1, x2, x3, let's assume that this is bank data. So what do you do in the bank data? There is an input called age, gender, transaction amount, EMI amount. And we are going to predict the customer is defaulted or not defaulted. The customer is going to be a defaulted or not defaulted. So that's what we're looking for. Okay, so what happened here? When we have the 100% of data, this needs to be split randomly. That's called random. We need to split the data randomly. Assume that this is balanced data set. Assume that this is balanced data set. So balanced data set, all of us know. Let me explain about this. See, balanced data set, when you have a numerical data or non-numerical, when your data is binary data, for example, yes or no, 0 or 1, true or false. Let's assume this is output. When your output variable is binary data, so the number of, for example, there are 1,000 customers. So out of 1,000 customers, what is the range? What is the count of defaulter, what is the count of not defaulter. Okay. So what is the customer? What is the default customer? What is the default or what is the not default customers? So what is the default customer? What is the not? So both any one single value should be, that value should be on both balanced. For example, can be 70 or it can be 30. For example, can you let us know? For example, we have a, just a minute, yes. Okay, so yeah, I got it now. So fine. So yeah, so where we are. So we have a data set with a supervised machine learning and unsupervised machine learning. Supervised and unsupervised. So supervised machine learning, we have come to know the split, random split. Contain the random split. Okay, so random split. In the random split, what we do, it is kind of 80 or 20%. Can be of 80% or 20%. So when you have a 80-20, that means when you have a 80-20, okay. So what happened here? If you have a 10,000 customer, first of all, let's check random. Sorry, my bad. Let's check balanced or imbalanced. So balanced data set, we have a 50-50% of data, and we have a 60-40% of data, and we have a 70 and 30. So these are called as balanced data set. So what is the thumb rule is any one of the column or any one of the classes, any one of the classes which is more than, okay, he's, so any one of the column should be, or any one of the category, that mean class exceeding 80%, that's called imbalanced. That is called imbalanced data set. Okay, imbalanced data set. If 50-50 balanced, 60-40 balanced data set, 70-30 balanced data set. So until this, we will consider as a balanced. So anything above will cross 60-40 or anything 80-20 or 90-10. This is imbalanced data set. So that is about one thing we need to consider in supervised machine learning. Okay, in supervised machine learning, we need to consider this. And what happened once we get data is getting ready, we need to split the data. Split happen 80-20% or 70-30. So why we give more partitioning? This is called partitioning the data set. This is called partitioning. That means split the data or partitioning the data, partition. So when you have a more number of data in your training, the more complexity model will learn. When less data in, when less number of data, when less number of data in your model, that means less complexity. Then less complexity. So that is called 70 and 30. Okay. All of you understand? So this is called supervised machine learning. So what happened here when you split the data? Okay, when you split the data, and what is the next? What we can do next? So we have 80 and 20. So data set is like this. You have a 80% of data. Then what we do? We build the model. We build the model. That means creating algorithm. So this is train and this is test. We train the algorithm. By using the algorithm, we are going to predict the data. Predict the data is it is unknown data. The data is unknown. The data, the algorithm will not familiar with the new data. If you are only training for this, so what do you do? We need to test the data. Okay, we need to test the data. Here the answer is hidden. So we need to predict the value. Take only input and predict the value. And we have marked as the actual value and prediction value. What is actual value means? We have historical data. So historical data, we have an answer. So that value is considered as a output. And this is prediction value. So now we can look at comparison. So we have a root mean squared error. There are multiple error metric we have. So ultimately we can use of it. We can use of it. So this is called error metric. Okay, next we have another thing, another options we have here is another options we have. Now, another machine learning is unsupervised machine. So this is what we are going to do. See, in unsupervised machine learning, we are going to talk about the topic of clustering. We are going to topic of clustering. Okay. We are going to talk about topic of clustering. So in clustering, okay, in clustering, we just came to know different type of clustering. Okay, so we have a clustering. The clustering means, what is the clustering? Clustering means grouping the data or segmenting the data. Grouping the data or segmenting the data. Grouping the data or segmenting the data. So grouping, what is grouping? Grouping is a classifying technique. It's a classifier technique, classifying. Okay, for example, the grouping, the clustering technique mainly used for marketing analysis or business side. We can call as targeting or positioning So we can call in different method. We can call it in different method: positioning, or targeting. So this is called clustering. So clustering means when you have a data, for example, when you are working in the bank, so the bank wants to increase their sales. So to increase the sales, what we need to do? They need to devise the strategy. That device the strategy can be varying from group to group, right? Can be varying from group to group. For example, students group, teachers group, or affluence community, right? Or the average spending, low capability of spending, low spending capability of student persons. So different kind of the variety of people we have. So everything. For example, when you are the importance of clustering, I would say when you are go with supermarket, when you are going supermarket, what do you do in supermarket? The all products are dumped. All are dumped into same product, same rack. No, right? So every product organized in a proper manner. Every product is organized in the proper manner, right? So every rack, vegetables one rack, fruits one rack, soft drinks one rack. So everything is a separate rack. Separate rack. What is the purpose of it? Because to get organizing capability. It's used for organizing capability. So everything, if you are everything in the rack, for example, here. Data is like that. So your data set is like that. So you are feeding into the machine algorithm. What algorithm will do based on the similar characteristics, it will be separate as a different group. This is one group. This is another group. This is another group. Right. This is another group. So that's what we used to find. So separate bit. This is separate percent. This is separate percent. So based on the distance, it's going to separate the group. Okay. So segmenting the data. That's called segmenting the data. Segmenting the data. So clustering mainly divided into two types. One is called hierarchical clustering. Another is called non-hierarchical clustering. Okay, so hierarchical clustering and non-hierarchical clustering. When come to hierarchical clustering, that is again divided subcategory into two types. One is called agglomerative. Another is called divisive clustering. Agglomerative and divisive. When come to agglomerative, that means in initial stage, each record is considered as a one cluster. Then based on the distance, it's for example A, B, C, D, A, B, C, D, and A. So when you are doing this based on distance, we are measure the distance to A to B, A to C, A to D, and A to U. Same way we can follow the A to C. So ultimately, what we need to create single cluster based on the similarity. Similarity means the clustering is mainly based on the similarity based technique. Based on similarity, we are grouping the data. How do we find the similarity? It should be based on distance matrix. It should be based on distance matrix. So this is overall talk about clustering topic. Okay. So first of all, we have to understand what is clustering. Clustering means grouping or segmenting the similar group of data, similar characteristic of data. Similar characteristic of data. So that is what clustering. After we understand the clustering point, then we will come to know type of clustering. So type of clustering, we have hierarchical. Hierarchical means follow order or some structure, hierarchical structure. Non-hierarchical means it doesn't follow some hierarchical structure. So we have a hierarchical agglomerative and divisive. Non-hierarchical, we have a k-means clustering. So today we are going to work with the k-means clustering topic. K-means clustering. And we have another data type, db-scan clustering. db-scan clustering to do. So k-means clustering, db-scan clustering. So what is k-means clustering? Let us look at quickly. And we have use cases of stock price prediction based on the cluster. So not prediction, it's kind of clustering. We are just making clustering on stock price. So what we need to do? We need to do. This is example of clustering. Input and we put, then we are grouping the data based on similarity. Similarity based on the group. So K means clustering. What does it mean? K means, so K means clustering. We need to understand the word called centroid. We need to call it centroid. Centroid means average. Okay, averaging the data. So what happened? So in K means clustering, the one important point is upfront we need to predict the cluster. See, upfront we are designing the number of clusters. We are designing the number of cluster. How many cluster you want? We need to upfront. We have to predict the customers. Design the customer. Sorry, my bad. We have to upfront. We have to predict the, or we have to design the customer. This is the number of clusters. Upfront, we have to predict the number of clusters. So once you find the clusters, once you design the cluster, then when you pass our algorithm, the algorithm will choose the random point, random centroid. For example, there are 3 clusters. If you are just give an input as a 3 cluster, let us think this is one data point. I'm sorry, this is one. So what we need to do, we need to find the distance between each data point to each cluster, each centroid. So we have to measure the distance between each data point into each cluster. So cluster data points, each centroid. So centroid we have, in the centroid, we are distance between each clusters. Okay. So once you find the centroid, so which data point is close to the centroid, it will forming the group. Forming a cluster. Then within a centroid, we have to find the average. Then again, we need to find the distance between the each record or data point. See, in hierarchical clustering, we used dendrogram to identify the appropriate cluster. But here we have used elbow curve. What is elbow curve? First of all, so before that, let us complete this. See, when you have a, let me open this Kevin's question. So what we do in the K-means cluster, we are initializing the some centroid. Initialization can happen by randomly. This initialization of point will happen randomly. The random initialization point. Just a so we have to initialize the centroid. How to initialize the centroid. This initialized happen by random. For each sample, there is a set of samples. And what happens, see, when you take like this, so each time the samples can be different. We need to measure the centroid. We have to keep centroid. The centroid will keep changing based on the iteration. Correct. Every iteration. For example, when you have a data like this. So what happened here? Once we set, for example, now let me clear. I'll use this blank slide so that you can able to understand. So let's assume this. Initially we pre-decided that we decided that there are 3 cluster I want. So I need this one. Random initialization. This one. So find the distance between each data point. Every cluster, every data point, every point. Find the distance in each cluster, and the data point is forming a cluster. Every data point forming a cluster. After forming a cluster, the centroid might be changed. After forming, so if you do the average can be like this. Then we need to find the distance. So that time, this value can be closest to this, also this. So this needs to come to this point, and we are finding average. So likewise, when you have more number of data, the iterations keep on doing that. We keep doing iteration multiple times until the data point belongs to only this cluster, not this cluster. That is with the appropriate cluster. That is appropriate cluster. So for that, what we are expecting, we used to have a WSS, VSS, TWSS. What does it mean? TWSS, VSS, and TWSS. That means when you have a WSS within sum of square, and we have a BSS. BSS means between sum of square. And we have a TWSS, total within sum of square. Total within sum of square. So there are 3, and within sum of square means when you calculate, add these things, you find the centroid and find the distance between each data point. Then you are square and summation of D1, D2, D3 like that. Over distance 1, distance 2, distance 3. So that is called within sum of square. So in one cluster, within sum of square should be closest minimum value. Distance should be minimum. Distance should be minimum means it is closest value, right? It is closest value. Then what do you understand business sum of square? Between sum of square. So between sum of square, we have a three variable. Let's assume three variable, three cluster. So you find the average for this, find the average for this one, we find the average for this one. So find the distance between the each cluster. Find the distance between the each clusters. Find the distance between the each cluster. So within a cluster, similarity should be less, but between the clusters, the similarity should be higher. Sorry, dissimilarity should be higher. Similarity should be less. Similarity should be higher. Similarity should be less. Then dissimilarity should be higher. When you have a clusters, so ultimately when you stop, that's what we can say it's a, let us in this. These number of clusters. When you want to stop, you have to decide. See, every time we need to random centroid, it reaches this point. This is called minimum point. So your success of the minimum point depends upon the random initialization. So we don't have control on the random initializations. We cannot get because it is random choice. So we can't get global minima. So this minima is called local minima. This can be minima, this can be minima. So we will do multiple iteration. Multiplication, it should become here. Not it should become reducing the error. Reducing the error means we keep on increasing the number of clusters. So ultimately, what should happen? The error should be minimized. Error means the variation should be minimized. Variation should be minimized. If variation minimized, that means all data have a similar characteristic. To understand logical thing point of view. Understand, guys? So in order to reduce the point or in order to term the error term, we need to keep experimenting. So we need to keep experimenting, and in during experiment, we need to select random initialization happen. We need to do random initialization happen. So here you can look at this. The initialization centroid. Center means it is called average. Just a minute, please. Just a minute. Okay, fine. Okay, fine. So the average centroid means it's the average. So the success of finding the lowest value is based on average, the initialization. So we need to recalculate the centroid. So every cluster there is a centroid. The centroid will keep changing and varying. So we need to redo that. We need to reiterate. We need to iterate every time and repeat the step until 2 to 3 stop is free take. Okay. So that is called so sample. So recalculate centroid based on the mean of sample in the cluster. So we have a SS sum of square distance. Error, sum of squared error. So how we calculate variance first of all? How do you calculate variance? The variance can be measured by x minus x bar divided by whole square. X minus x bar divided by whole square. So we have word link. There are different linkage also. We have single linkage, complete linkage, and average linkage. So average linkage means when you have a two cluster, find the average, and find the distance. That's called average. Central. So we have a different kind of evaluation technique. See, we create a cluster. The cluster can be decided based on TWSs. So when you have a cluster 1, cluster 2, cluster 3, and cluster 4, here it can be TWS, WS, W2, keep on increasing. WS, total WSs. So you want minimum WSs within sum of squared error should be minimum. The variation should be less. So this particular point of time, less variation. So we can decide it 2 is the appropriate cluster for us. So 2 is the appropriate cluster. This is we can do it by using elbow curve or scree plot. Okay, scree plot or elbow curve. Okay, fine. There are some challenges we can follow here. For example, for stability, run the k-means clustering multiple times called iteration. So the problem here is we don't know which is the exact solution. See, every time there is a different minimum value. The error, for example, when you do that, So when you do this, if your random initialization happen here, this is lowest value. If your random initialization happen, this is lowest value. This lowest value. This lowest value. So that is the way it keep changing. Keep changing differently. So we have different choosing keyword. So this will address the multiple local minima value. Multiple local minima. So the data point might keep oscillating between two clusters. For example, when you are changing the cluster, the data point, right? Let's assume the data point keep on changing from one cluster to another cluster. Okay, fine. So every time initialization, the data point is keep oscillation. From to here and from to here. So when will it get global? We don't know because that's happen on random, right? So how can we get the global minima every time? So that is what choosing appropriate one. Second thing, conversion criteria. Conversion criteria means when you are keep changing, when you are do reiteration, the centroids keep on changing. At particular point of time, one data point can be always will not be stable with any one cluster. If you do so, it will come here, come here. So we can choose some maximum number of iterations. In this iterations, whichever possible, we can consider. Sometimes we can see the less percentage. Third thing is something better to stop. When percentage move less than certain percentage, smallest distance, many percent. That means what we expected, the centroid should be within the range of cluster. But it can be some buffer. Something can be okay, even though if less percent, that's fine. You can keep that. The percentage of smallest distance also can be a centroid. So that things is we can consider this. And we are compare the between cluster variation within cluster variation. Nothing but compare between the cluster variation to within cluster variation. So the function which we are using is sum of squared error. Sum of squared error. And these are the package we used here. Let me look. K means equal to, for example, here we put number 12. Number 12 means it is the number of cluster we use. And maximum iteration 300. Number of clusters should be called. Algorithm means auto algorithm. So when you use this, you used to get like this. So we can look at them. We can look at some use cases of it. Okay, now what we do, let me so let me download the file. So just keep loading now. Yeah. So now we have a data set. And what we are doing here is, see, I'm not going to run you to take time. So already I run it and I'll explain you how to do the what is structure for this. We can get the output of that. Okay. So now we are just loading library called data.table. This is for big data. Okay. And we're giving a copy path and read the file. So we have historical stock prices as a data frame. See, we have to take some historical data. Okay, some historical data. But so from the historical data, we are making head historical price. So we want to know what the first 6. We run it. The first 5 header up. That's what we used to head. Okay. Let me do that. Correct. So now we used to get the head of that. So if your data is like that, we can't able to understand anything. So what we need to do? We are having another data frame. We are converted into the data frame. The historical data converted into data frame. So we have a ticker, exchange, CHR. These are the name of the name sector. These are all the number of that. Okay. Just a minute. So ticker, yes. So sticker will update the report of price of certain securities. So this will be updated continuously throughout the trading session by the various stock exchanges. So any change in the price of security, this will be moved up or down. Ticker. The symbol of the New York Stock Exchange. It contains 4 letters. Why it is called as ticker is a symbol of unique 5-letter code used by the stock exchange. Okay. Then we are just loading. We need to access the data from the SQL point of view. SQL. So we are installing SQL. In SQL by using R SQLite and install package from SQL DF. So, and also we are using some the dependency packages also used to do the and we done it. Then we are using some queries for SQL. So select sort from stacks where date. So we want to take a data from particular date 24/8/2017 to 24/8/2018. So we make stop 2018 and we use the symbol from it. Select stop. So here we use select. Select means in the data set, we select the data, select start, all the column we want, all the reels we want. From stocks where, from means which period to another period. So in the date, from stocks, we have a stock. In the stock, where date between 24/8/2017 to 24/8/2018. So that will help you. That will help you to get a data from particular time period. Okay, so now that same thing here, we are using some SQL queries. And now we are changing the data format. These all are from basic SQL formats. I'm using SQL format. Then we are changing the format of that. Okay. So by changing the format, we can find out what is the data frame. So we need to know count, how many counts are there. For example, here we are looking for, as we mentioned, SQL in R. So we can use by using R. Okay. So we are going to use SQL in R. To do this, we need a library called SQL. So we need to do netjoin and we need to ticker in the format. So that we can done by using installation. So we will pick the industry with the highest count in ticker. So what we mean by we can have first level industry to be a corresponding one. So yeah, so the overall what we are doing, we are changing the format by using stock industry. When you are using group by or, we used or by using or we can download. Okay, what happened here? We can get some outlier on it. We used to get some outlier. We used to get the outlier for the data set. So what we need to do? We need to change. We need to handle the outlier. We have an outlier treatment, right? So we need to change the outlier. So after we remove we used max whisker plot, lower and upper whisker plot. So when we done it, we removed our outlier. Then we can have a library called TIDAOR. So this is the R programming language. So we can use it by R as well as we can use it by Python also. So both way we can configure that. So now we can come to the main topic of k-means clustering. So in the sections, we are going to look at k-means clustering from out of data set called rem_cache. Remember that label TNC analysis. See, when you do so, we have a rem k-means. In the k-means, we can start from the 25. So iterations, we can have a 25, 20 iteration and start with 25. So ultimately, we used to get the output of like this. So 11 clusters. So in the appropriate data set, we used to have 11 sector. But what we need PC1 technique, right? We have to use PC1. Since we have more number of data, we need to PCA. Then we are looking for elbow method. Elbow method will choose how many clusters can be appropriate for that. So here, how many clusters we can choose? So for us, we have 11 choice. So 11 should be appropriate over here. So we are not going to choose any other value. So when you do perform all these things, you can do it by Python also. So since I don't have a Python code now, I can run it on this notebook in or itself. So there are various things we have. Just a minute, guys. I will look at if there is any other format I have. Just a minute. Okay, at the moment, no, I don't have data sets. Yes, okay. So when you are coming tomorrow, okay, this is we are stopping. So we created by using our program and language, we created 11 clusters. So 11 cluster could be an appropriate one for this clustering in K-means clustering. So we have a principal component. What we do by principal component, guys? So we need to do principal component also, because principal component also will help to reduce the column. To reduce the column, you can able to reduce the column, right? Without deleting data. Without deleting the data. See, in the next scenario, in the next applications, we will use our evaluation for supervised machine learning. Yes, we used to do evaluation also. So in the K-means clustering, we haven't done much about it. Okay. Since we are using R, so we can able to we had the limited things. And when I'm using Python, we used to see we used to look at in the Python. Okay, we used to look at the Python. So with this, we are stopping today. With this, we are stopping, and we will see tomorrow in detailed manner.